In this video, we're gonna look at Lambda with a receiver, also called function literal with a receiver. You will find this feature in Kotlin if you look at the source code of some libraries like coroutines or Jetpack Compose. So if we take a look at their website, as you can see, this column function uses a content parameter that has this weird looking data type, has this column and dot, parentheses, arrow, something we haven't seen before. So if you look at the coroutines run blocking function, you can also see they also use the same thing. So this syntax is called Lambda with a receiver. And these are extensively used in libraries to write concise and readable code. So what's a Lambda with a receiver? It is a unique capability of Kotlin that allows a Lambda function to be invoked on a receiver object, giving it access to the receiver's methods and properties within the Lambda body. You'll see what I mean in a bit. So before we continue, I'm going to recap what a Lambda expressions is. Then I'm going to show you how to use Lambda with a receiver. Lambda expressions are known as function literal. With Lambda expression, you can create a function without providing a name. And you can also easily assign this function to a variable. Lambda expressions are most commonly used in higher order functions. Higher order functions are just functions that accept other functions. You'll see Lambda expressions are used like parameter for these functions. Let's jump into our code editor and try to write a Lambda expression. I will be using the IntelliJ IDEA. So here we have a variable called add, and this has this data type, which is just this is just a functional. This is called function data type, right? Inside of the parentheses, we have two data types, two parameters that has this integer data types, and this returns an integer. So in the Lambda body, I'm just using the variable names and returning, adding. So this is just some Lambda expression. We know how to write Lambda expressions, and we have been using it. So this calculate function is a higher order function. This, if you look at the functional signature, it expects three parameters: a, b, operation. So a and b are just integers, and operation is a function. It expects a function. So we can use this add function because it has the same signature. And it returns an integer. And it calls the operation passing in these two variables passed to this function. Okay, now when we call calculate, passing in values for a, b, and add, a, b, and operation. For a, I'm using 1 and 2 because these are just integers. And operation, for operation, I'm using the Lambda expression. So we just passed a function to another function. So that's how typically Lambda expressions are used. As you can see, I passed a variable to this parameter. Instead, we typically just write Lambda expression in this place, which is just called a trailing Lambda syntax. So this is how we typically write Lambda expressions. Okay, now let's look at how to use Lambda with receivers. Okay, here's a lambda with here's a lambda with a receiver. So I have a variable that has this function type. As you can see, we can see that this is a lambda with a receiver by looking at this syntax. We have a data type and a dot, and then some data type we typically use, and then we have a lambda body. It kind of looks like a regular lambda expression, but it just has a slight syntax difference in how we provide the function data type. So what does this do? When you use this, you can sort of reference the receiver object in the body of the lambda expression. Here, the receiver object is this one. So this is a primitive data type. So we can reference this inside of the lambda body. So this is the lambda body inside of curly braces. So the receiver object is whatever before the dot, right? This receiver object becomes implicit this inside of the lambda body. So we can just use this to refer to the receiver object. In our case, it's just integer. Now we can access any of its properties or methods, but since it's implicit, you can just you don't have to use this keyword. It automatically thinks whatever properties you called is being called on the receiver object. So inside of this lambda body, you can call the property or methods of the receiver object, kind of like scoped functions such as apply or let. Here I call the plus method that every integer object have, and I passed integer variable. And to use this, you can so essentially what we wrote is kind of like extension function at the moment. So first we are using object, so integer object. So any number is just an integer object, and integer objects now have a add method, kind of like extension function, and then this add method has this kind of signature. So we just pass a 5 for the first parameter, and then it returns integer. So when we call add method, it just runs this block of code and then calls the plus and returns the plus something, this expression. This is one way of using the lambda with receiver, but libraries such as Jetpack Compose use lambda with receivers in function parameters like this. As you can see here, the content parameter has this type that indicates that this is a lambda with a receiver, and the receiver object here is just a column scope. Let's create something like this on our own. Okay, first I'm going to create a class with some methods that we can call in the lambda body. Okay, this is going to be our class. So this class has just one method, greeting, and just it returns a string. Okay, now I created another function and I used lambda with the receiver in the parameter. So, and this returns nothing. So that's why I used the unit. And inside of this function body, I'm creating an instance of greet class. So, and then I'm calling the block method or parameter or whatever. So to use this, I'm gonna call the greet fun, and then I'm gonna use a trailing lambda syntax. And inside of this lambda, because we use the this lambda with the receiver, I can call the any method of greet object inside of this lambda. For example, I can call greeting, and for the name I can pass any string, right? So you create a function and then you create a parameter that has this lambda with a receiver function type, and then you need to create a instance of that object, and then you just call the you just call the lambda with the receiver parameter thingy, and then you can just call the methods of the object inside of the lambda body. So this is a more advanced usage of this lambda with the receiver. So currently we are calling an HTML function, and then we're calling body and h1, and we're just nesting some function calls. So we're just nesting it. Just look at how nice it is to look at it. If you have used HTML, you will notice that this body and h1 are tags that can be nested inside of h1 tags can be nested inside of body. It just intuitively makes sense to use it like this. With the help of lambda with receivers, you can create your library to be written like this. You can kind of see Jetpack Compose is kind of written using this Kotlin feature. So that's why it kind of looks easier to write a Jetpack composables or some things like that. So first, we're gonna look at how this is created. I'm not going to be creating this one. So essentially, we won't be writing any code that uses lambda with receivers on our own, but I think it's essential to understand how other libraries use lambda with a receiver. So first, we're calling HTML function. So here the HTML function has this lambda with a receiver in the parameter, and then it returns a string. And then we're creating HTML object. So let's look at the HTML class. So this HTML class has elements, property, and h1 body, and then 2 string methods. So I believe in the HTML lambda, we can call all of these methods. So first we're calling the body. So if you look at the body, this also has this lambda with a receiver. So if we do call this body with a lambda, we can still call the methods of HTML object. So that's why we were able to call the HTML objects h1 method inside of this body lambda, and it has all of this stuff that does behind the scenes. After that, you kind of end up with something like this. So with the help of lambda with the receivers, you you could write HTML builders. I think you can easily find how to create this HTML builder if you search for a bit. So I don't think it's kind of complicated. So I'm not gonna explain this. Now let's take a look at how the Lambda with receivers are used in actual libraries such as Jetpack Compose. We can look at the source code of any of functions or classes or whatever. So I'm going to go to the column source code. So in the column source code, obviously they're using this column scope as a receiver object. But if you look at the column scope, it is actually an interface. So one that implements this interface is, I believe, this column scope instance. Column scope instance is the one that implements the column scope interface. This is a singleton object. I think it's internally used. So in the Lambda body, we can call the methods of this object, right? But there is no single methods that you can call. Instead, it's kind of like as these extensions on a modifier object. So there's nothing you can call inside of this Lambda body. Okay, I'm gonna open up the Visual Android Studio. If you have inlanes turned on, you can see in the Lambda body what this refers to. In this case, this refers to column scope. So we can call column scopes methods, but as we saw, there's no methods that we can call. Instead, there is just extension functions and modifiers. Let's look at the run blocking. If you look at the run blocking, they're using the coroutine scope as the receiver object. But if you go to the documentation, you can see the coroutine scope is not is an interface. This interface doesn't have any abstract methods. This has just one property, coroutine context. But if you ever use the run blocking function, you can see that in the Lambda, you can use launch method. But we didn't see the launch method in the coroutine scope interface. So where is it? If you look at the documentation a little further and search for launch, you can see that this launch method or function is just an extension function for the coroutine scope interface. So there's a launch method, but it's just an extension function created somewhere, I guess that's pretty much it. We looked at how to use the Lambda with receivers. We won't be writing Lambda with receivers on our own anytime soon, but I think it's something to be aware of, I guess. I'll see you in the next video.